Kia ora Year 12. I've picked out two questions from the 2004 A-level paper to look at today. They're both reasonably straightforward, a couple of little details as usual that you have to get your head around. So pause the video and have a go at both of them. The first one will use implicit differentiation, and the second one had a hint given in the paper that I've meanly decided not to give you to see how you get on. Okay, so the first question is a straightforward implicit problem. The tricky term in here is going to be the 4xy, where we're going to have to use the product rule. We're also going to have to use implicit on this part here, but it's not too bad. So starting differentiating term by term, we get 4x coming from the 2x squared minus, now I'm going to go slowly through here, so we're going to differentiate this and leave this using the product rule, giving me 4 times y, and now we'll switch it. We're going to leave the 4x and differentiate the y. So differentiating the y gives me 1 times dy by dx, and then moving on we get plus 6y dy by dx equals 0. So don't forget about this bit here. This is not going to stay as 3. So you can think about this as a flat line at 3, so its gradient will be 0. Now we need to just do our cleanup. So we have 4x minus 4y plus dy by dx. I'm going to reorder things a little here. Dy by dx times 6y minus 4x equals 0. So rearranging that, I get dy by dx equals 4y minus 4x over 6y minus 4x. We can simplify that, dividing through by 2. And the last thing we need to do is to substitute in the point 2, 1. So dy by dx will be 2 1s minus 2 2s over 3 1s minus 2 2s. Now, you know, lots of you are still making really small errors when you're in a hurry. So I really recommend that you actually show that substitution. If you're sitting in the exam, or in real life as well, it makes it so much easier to go back and check whether you've mucked it up. Okay, and it's pretty easy to screw these up, especially when you're in a rush. So there we go. The answer is 2. So the gradient of that curve at the point 2, 1 is 2. Now we're going to look at the next question, which is slightly more involved. So I think this one was worth 4 marks. Right, the next question is a 6-mark one, and we're being asked to solve this. Right, so the first thing you were actually asked to do in the question was to show that it could be written as a quadratic in y or in u. Now, we've done lots of problems where we have to use this strategy, but we're going to do it by saying let u equal 2 to the power of x. So now I've got u minus 1 over u is equal to 1, which gives me u squared minus 1 equals u. That's timesing both sides through by u, which gives me u squared minus u minus 1 equals 0. Pretty sure we had this particular quadratic come up in class last week in exactly that form. So we're going to solve that now. I'm going to do it using the quadratic formula, and that will give me 2 solutions. Okay, so u squared minus u minus 1 equals 0. U is equal to this. We've got a is 1, b is negative 1, c is negative 1. I know some of you are going to skip through some of this, that's fine, but make sure you've got your working clearly set out. Right, so that's 1 plus or minus the square root of 1 minus 4 times 1 times negative 1. Again, the reason that I'm writing it in this really, what feels quite babyish way, is so that we don't muck up the negative signs, right? Because it's very easy to miss a negative 1 in there. So there's that. So u is equal to 1/2 plus or minus the square root of 5 on 2. But we know that u is equal to 2x, and 2x is strictly positive. So 1/2 minus the square root of 5 on 2 is not a solution. So we're just going to keep going with the positive solution to that equation. We've got a little bit of work to do yet. So we're going to ditch the negative and keep on going. So now we're at this. 2 to the power of x is equal to 1/2 plus root 5 on 2, which is 1 plus root 5 on 2. A couple of ways to go here. We can take logs to base 2 on both sides. That's probably the nicest thing to do. Gives us a lovely analytical answer. But it's not going to help me for when I need to get a number on my calculator. So we'll look at doing a change of base thing later on. But first, let's do the log to base 2 on both sides. That gives me x log to base 2 of 2. Over here, I can simplify this as follows. So the log, what number? 2 to the power of what gives me 2? That's just 1. So sorry, that's just this mobile phone. And this is staying the same. So that's my lovely exact answer for x. But I did notice that in the schedule they've gone with a very ugly 0.6 something something. So I wanted to make sure that you could all do change of bases really easily using your non-graphics calculators. So we're just going to do that on the last slide, so just be patient. So we've got x is equal to the log to base 2 of that. But we can't put that in the calculator because there's no base 2 button. So we're going to change it to the natural log, or we could do log of base 10, log to base 10. So this is how we do a change of base. Now that should be starting to feel really, really comfortable because we've done that in scholarship sessions quite a few times now. And the rule is this, that if I've got a log to base A of B, then if I want to make it to a new base, I just do the new base on top and then I adjust as follows. Okay, so that's what I'm using there. And I can't remember the number that we get for that, but you can chuck that in your calculator and get it. Hang on, it is here. It's equal to about 0.694. Okay, thanks for watching. There's quite a lot of good stuff in that question on logs. So if you found any of those log steps tricky, do make sure you go back to the textbook and go over it, or send me an email. Thanks for watching.